So hello and welcome to the video about VPython. So we're trying to see what will happen and how can we get dot product, and we're going to use it by seeing the changes in VPython. So VPython is going to give us a vector A, 3 x hats, 4 y hats, and 0 z hats. And you have this vector. I give us actually a color. It did not have the color in the beginning. I said because we want to have also add some vectors. Maybe this has to have a color is like better. So I'm gonna give it the color, and then we have the printed magnitude vector A. So when I get that vector A, I'm gonna get this that has been printed over here for us. So we have, if I put 3, I'm supposed to get a magnitude of 5 and the arrow. So let us see what will happen if I give it a z hat of 1. So it comes down, you have a raise in magnitude. So doing 5.099, I will say 5.1. You can also count as a 5, not me 1. But now let me not change that one, but let me change 241 and see what we get. So it's been reduced to 4.58. So what I'm seeing is that it takes the magnitude of our vector and get it use that to get magnitude. So we're gonna use the component of magnitude, and we did this a lot in videos. So it's gonna get square all the magnitudes, get the square root of the sum, and then give us the magnitude which is over there. So you'll see I want to get a vector that is actually double than that, and then another vector that you all have the same vector magnitude. Let's see if we can do that. So I mess with vector B a lot, and I give the new color green. That's vector B, and then vector A. As you can see, we have 4 and 8. So you can see the vector that has been blocked on the VPython is from the components that we have, and for the magnitude is using those components to give us a magnitude that we really needed. So that's how we can get on all that, getting all those components to give us magnitude, and we use to manipulate them to building a vector based on those. Now another thing is that we can see here is that I double the vector, so I give a distribution of 2, although I actually missed a little bit, but you can give it times 2 to get a magnitude that is double than that. So that's how we can get the magnitude and the components. So hopefully we can see if we can get a similar, so we have all in the same, but the points are not the same. So hopefully we can see if we can do a vector C, and then we can make them equal to each other. As we can see, I really love this because I have different points for all of these vectors, and we have different colors. The green one is vector B, red one is vector A, and the yellow one is vector C. And I get perfectly all of them similar, 6.40, like all of them is that way, but I have different dots. Although maybe they have like some similarities. For example, vector A and vector B have like the similar x hat, like 4, 4, and then you can also see, but no, on the other ones they don't have any similarities on it. Maybe this one is actually a little bit like being reused on that one. So we can see that we actually get 3 vectors with the components that build them, and then the magnitude is going to use those components to give us a magnitude, give us a scalar, and you can see how the vectors are going to be used in this format to give us magnitude and being built by the components and give us a direction, and we should magnitude to describe us the vector. And we can see when I rose those, when I have a 7 on x hat, I had getting my magnitude getting larger, but when I actually decrease the values of any of those components, I get lower magnitude. So you can see how the length will also affect the magnitude of our vectors and building blocks. So hopefully you guys learned something new, and I see you guys next time. This is VPython.